AI coding agents are starting to look less like autocomplete and more like full systems that can inspect a repo, reason over structure, and decide when execution is actually worth the cost. But the surprising part is that brute force more is not always better. The gains are often real, yet narrow, and sometimes the cheapest path is the smartest one. What connects these results is a shift from "can the model do it?" to which signals and feedback loops actually improve output. Keep watching, because the details are where the engineering strategy gets interesting. Let's explore the first paper: GitHub Copilot and Developer Productivity and Observational Dose Response Analysis. This Microsoft study, GitHub Copilot and Developer Productivity and Observational Dose Response Analysis, uses 43 weeks of telemetry from 16,223 engineers in Microsoft's Cloud Plus AI organization to estimate whether GitHub Copilot improves output beyond simply being used by stronger or busier developers. The authors avoid an infeasible A/B test and instead fit a Poisson pseudo-maximum likelihood model with engineer fixed effects, weak fixed effects, and controls for coding time and browser time, so the estimand is an efficiency effect. More completed pull requests at the same measured effort. In the main depth-based specification, weeks with the highest Copilot usage show a 40.5% increase in completed PRs relative to zero usage weeks, with a monotonic gradient across low, moderate, and high usage and evidence of diminishing returns at the top end. They then run 7 falsification checks, including a non-coding Microsoft 365 Copilot placebo, a teammate PR placebo outcome, lag, lead timing tests, PR size decomposition, PR type decomposition, and an alternate breadth-based treatment definition. These largely rule out generic AI engagement, team-level shocks, within-week task reallocation, slicing into smaller PRs, and easier task mix as simple explanations. The breadth-based robustness check still shows a 54% increase at high usage, reinforcing the same qualitative conclusion. Within engineer Copilot-heavy weeks are associated with substantially higher PR throughput, though the paper emphasizes that this remains observational and likely understates any total effect if Copilot also saves time. Let's explore the second paper: LLM agents can see code repositories. LLM agents can see code repositories is a systematic study from Shanghai Jiao Tong University and Zhejiang University, showing that multimodal large language models can use visual repository structure as a useful complement to text for software issue resolution. The authors build Repo, which converts AST-derived repository graphs into GraphViz images over 4 relations: contains, imports, invokes, and inherits, and evaluate GPT-5, Mini, GPT-5, 1, Dubao, Seed, 2, 0, Lite, and Kimi K, 2. 5 on SWE Bench Verified, SWE Rebench Leaderboard, and SWE QA. The key result is a sharp boundary between vision-only and multimodal access. Replacing text with graph images drops pass at 1 by as much as 34.1 points and raises cost by up to 268%, while adding visual structure alongside text cuts, input tokens by up to 26%, and cost by up to 46% without sacrificing accuracy. On SWE Bench Verified, GPT, 5 Mini reaches 55.4% pass at 1, with Repo versus 55% text only, GPT-5. 1 drops slightly to 48.8%, but halves cost to 0.0975. Kimi K, 2. 5 improves to 70.6%, and Dubao, Seed, 2. 0. Lite rises to 52%. The best visual design is a graph layout with adaptive hop depth, and visualization is most effective during fault localization, not repair or validation, where late-stage structure adds noise rather than signal. Let's explore the third paper, To Run or Not to Run, analyzing the cost-effectiveness of code execution in LLM-based program repair. This ISSTA 2026 paper asks whether iterative code execution is actually worth its cost in LLM-based program repair using Claude Code from Anthropic, OpenAI Codex, and the open-source OpenCode with Qwen 2, 5, Coder 3, 2b across 7,745 SWE Bench leaderboard traces and 3,000 controlled repair attempts on 200 SWE bench instances, the authors isolate execution access as the only variable across 4 paradigms. They find that agents execute frequently, 8.8 test runs per task on average, ranging from 2 to 19, but the marginal value is small. The prohibited versus unrestricted resolve rate gap averages only 1.25 percentage points for commercial agents and is not statistically significant. On Claude Code, prohibited reduces token use by 56-62% and wall clock time by 48-54%, while keeping resolve rate within 1 to 3 points of unrestricted. On OpenCode, the gap is approximately 0 points. The study also shows that execution benefit is highly uneven. 54-66% of commercial agent cases finish in a single edit. 48.8% of Claude Code's reproduction executions produce actionable localization feedback, and 81-100% of failed cases can pass the agent's own validation, but still fail SWE-Bench's official tests. Late-stage executions perform better than early ones, with an average success rate of 57.9%, but overall, the paper concludes that code execution should be treated as an explicit resource with a cost-benefit threshold, not a default capability. That's a wrap on today's AI paper highlights. Thanks for watching.